Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be talking about priority queue, which is a special type of queue in Java that orders elements based on priority rather than just their insertion order. It's really good for task scheduling, shortest path algorithms, and event-driven simulations. So first, let's start with the required import statement. This time, we only have one required import statement. That statement would be import java.util.priorityQueue. So the priority queue class is part of java.util, so we have to import it before using it. It implements the queue interface but follows a specific order where the smallest or highest priority element is always processed first. So let's talk about how you create a priority queue. But before that, we have to start our class and our main method. So our class name would always be main, since our class name must match our file name. Now let's get started with our main method. Our main method would be public static void main string and string and args. So now let's create a priority queue. The way you do that is priority queue, and our data type is going to be integer for now. Sorry, I saw integer, and let's just call it PQ for priority queue. So equals new priority queue. It's pretty similar to how you define a linked list or an array list. So we can add some elements to our priority queue. So we can just do pq.add, let's add 10. pq.add, let's say 5. And pq.add 15. And let's add one more. pq.add, let's do 1. So let's try printing out our, using IntelliJ's built-in shortcut sout, let's try printing out our queue. So when we print this out, we get our queue. Notice that it's not in its insertion order because I added 10 first, then 5, then 15, then 1. If it was like a normal queue, it would be 10, 5, 15, 1. But since it's priority queue, it places the first elements, the smaller elements, sorry, at the start of the list. Which, if we have a queue full of random integers, it'll already be pre-sorted in case you want to use it for anything. So, in this code snippet, we created a priority queue of integers and we added elements to it. But unlike normal queues, the elements aren't stored in insertion order, as I said before. They're stored in a way that keeps the smallest element at the front. So next, let's talk about removing and polling elements. So the way we would do this is basically, so there's some methods and some terminology that you have to get familiar with. So let's just print this out just to see using IntelliJ's built-in shortcut. The first one is peak. So pq.peak, it essentially sees the highest priority element, which is, if you're paying attention, the smallest value. Another method is polling. So let's use the shortcut again. pq.poll. So the poll method removes and returns the element with the highest priority. So if I run this, I'll get 115, 1. Peak essentially takes the highest priority element. Poll would also do the same thing, but if I print my priority queue after I finish using these methods, using the shortcut, let's print out PQ, you would see that 1 is no longer there, since poll just prints out the highest priority element and it removes it from the actual queue. So notice how the smallest number is removed first. So next, let's talk about using custom priority. So priority queues, at the start, like by default, they place the highest order. They place the smallest value as the highest priority. But what if we could change it? That's where we use comparators to ensure custom priority. So let's call this max PQ. We're naming it because I would like to show something. Give me 1 second. Alright, max PQ equals new priority queue. And in this, we have AB. So if I have two sets of numbers AB, we make a pointer that goes to B minus A. So let's add some stuff to our max PQ. So max PQ dot add 1, max PQ dot add 3, max PQ dot add 7, max PQ dot add like 17. So let's say we print out this max PQ. So system.out.println shortcut, and then PQ. Sorry, max PQ, not just PQ, sorry. So if we do this, we see that it's in different order. So this comparator essentially ensures that the highest value elements now take the highest priority, which shows how we can use custom comparators to create a custom priority. So by default, priority queue sorts elements in ascending order. If you want a max heap where the largest number comes first, we would use a custom comparator. Now the largest number is given priority instead of the smallest. So let's talk about using priority queue with strings. So to do this, we would change the data type that we're using for our priority queue. So let's create it. So priority queue, and data type would be string, as we're going to use that. Priority queue string, let's call it words, equals new priority queue. And now let's add some stuff to our list. To our priority queue, sorry. So let's add words. Let's do words I'll add. Super words dot add 7 words dot add super 7. Now I'm going to add something here. I'll explain what this snippet at the end does at the end. So while exclamation mark words dot is empty, we print out using the shortcut words dot poll. So priority queue, it also works with strings. By default, it arranges them in lexicographical order, essentially the alphabetical order from A all the way to Z. So if we keep polling this, we get the words sorted alphabetically. So if I run this, it would be 7, super 7. 7 would come first because numbers are given priority over letters in lexicographical order. So if you've ever played online video games, that's why you would see the players with like numbers or like special characters first rather than like actual characters. So when should you use priority queue? So you should use priority queue when elements need to be processed in a priority-based order. In algorithms like Dijkstra's shortest path, which is a pathfinding algorithm used for higher-level competitive programming, or Huffman coding, which is a special type of coding similar to dynamic programming, when sorting dynamically while adding/removing elements. So, in conclusion, priority queue orders elements based on priority, not insertion order. The default order is ascending, but we can change it using a comparator. It's useful for scheduling tasks, graph algorithms, and real-time processing. If you want to dive deeper, you can try implementing a real-world scheduling system using these priority queues. So thank you guys for watching this Super 7 programming tutorial, and see you next time.